Hi, my name is Antje Bard, and I work as a developer advocate for AI and machine learning at AWS. Let me just spend a couple of minutes here before we start in sharing how AI and machine learning runs on AWS. I think we all agree that the reach of machine learning is growing and has grown tremendously. We can see AI and machine learning being a core component and disrupting all of the industries. Whether we look at automotive, at healthcare, finance, you name it. If we look at Amazon.com, machine learning has been at the core of our development for more than 20 years. Whether you look at product recommendations on the Amazon.com website, or natural language processing as part of the Alexa devices, or more recently, looking at autonomous drones that help delivering packages with Prime Air. Our mission here at AWS is to put machine learning in the hands of every developer. So let's have a look at how the AWS ML Stack looks like. As you can see here, we categorize our machine learning services into 3 layers. And let's start here at the bottom layer. This is the frameworks and the infrastructure layer. Zooming into this infrastructure layer, you can see that we're offering a broad variety of frameworks and interfaces for you to choose. So this is really where the ML practitioners come and pick and choose whatever they want to work with. So you can pick any of our NVIDIA GPU-powered instances or any of the other instance families and work with frameworks like TensorFlow, PyTorch, or Apache MaxNet, among others, to build and train your machine learning models. Here's a quick overview of our GPU-accelerated instances powered by our partner NVIDIA. And you can see here we have the P2 and P3 family, consisting of the V100s, of the K80s, and then also we do have our G4 instance families that are powered by the T4. All right, coming to the second stack, which is the machine learning services. And this layer really consists of Amazon SageMaker. Amazon SageMaker is a fully managed service that helps you to build, train, and deploy your machine learning models at scale and quickly. So if we have a look at the traditional machine learning workflow, it consists of a lot of different steps. So you start by collecting and labeling the data. You then clean, format, and transform your data before you can even start developing your models. You then start training and also evaluating the models, and you keep adjusting until you find a good model. You then deploy that model into production and it starts serving predictions. But even in production, you have to keep managing your models because you want to be able to detect model or data drift early on. Amazon SageMaker is providing you with tools and services which assist you in each of those steps in this machine learning workflow. So for example, for labeling data, you can leverage Amazon SageMaker Ground Truth. And then you can move into hosted and managed Jupyter Notebook environments to actually pre-process your data and then start developing and training your model. Amazon SageMaker also supports and makes it really easy to train your model and then deploy the model into the cloud environment. Here's a quick look at how Amazon SageMaker Ground Truth can help you. By leveraging either public or private workforces, you can give the task of annotating data to those teams, which then help you to go and annotate through the large data sets at scale. Moving on to the Amazon SageMaker Notebook instances. Those are fully managed instances ranging through a variety of instance choices, again, from smaller types like the T2 up to the GPU-powered P3 instance family. They come pre-installed with Jupyter and Conda environments, So it's giving you a quick start really to get going and develop and train your models. Next, let's have a look at the options for model training. With Amazon SageMaker, you can choose between a couple of different ways to do training. Option number one is you use a built-in algorithm. And SageMaker, by the way, comes with 17 of those. The second option is that you provide your custom training script with a supported framework. The supported frameworks are Apache MaxNet, TensorFlow, Scikit-learn, PyTorch, or Chainer. Another option for you is to bring your own algorithm and framework. So you can leverage Docker containers with your own algorithms and frameworks to deploy with SageMaker. And then the fourth option is that you just pick and choose a ready-to-deploy trained model from the AWS Marketplace. Let's have a look at the deployment options. So once your model is stored in Amazon S3, again, you have a variety of options here. You can use the Amazon SageMaker real-time endpoint, which is really a one line of code to get your model out in production. Another option is if you're doing batch inference to use Amazon SageMaker Batch Transform. It predicts and stores the data again in S3. Then you can also deploy your models on Amazon's container services. So for example, ECS, EKS, or Fargate. This is specifically interesting maybe if you're using your own containers. And then really anywhere you like. So you can also just grab the model in S3 and run. The first two options, Amazon SageMaker Real-Time Endpoint and the Amazon SageMaker Batch Transform, are fully managed deployment options built in with SageMaker. Now let's move to the top layer in our ML stack, which are the AI services. And as you can see here, AWS has a variety of options for you for ready-to-use AI services. Here, you don't necessarily have to have much experience with AI and machine learning. You can just use any of those services and build your use case. Let's have a look here at the vision. Amazon Rekognition is a fully managed deep learning-based image and video analysis service. And this is super easy. So you basically provide the service with your input data, and as you can see here, the service has built-in capabilities to automatically identify and label the objects in your image. But it's not only that, so there are a couple of more use cases that are working out of the box. Next to labeling, you can also use Rekognition to do a face search, to identify unsafe images and videos, to detect faces or text and images. You can even use Rekognition to recognize celebrities, and you can do pathing and also real-time video analysis. Another strength of Rekognition is also a functionality called custom labels. So you might have use cases where the pre-trained model is not specific enough for your domain images or videos. So in this case, you can leverage custom labels to extend the detection abilities to find new objects and scenes in your images. And you do that by simply providing it with a small number of training images that you label, and then we create a custom model behind the scenes and then are then able to detect and label it according to your specific needs. There's also a lot of opportunity for partnerships. For example, with the AWS Marketplace for machine learning. It's a curated and trusted catalog of over hundreds of machine learning model packages and algorithms as of today. The AWS Marketplace makes it easy for startups to grow at scale. Your brand and products can be discovered by over 140,000 AWS customers who use the marketplace each day. Also, have a look at the AWS Data Exchange. It's a new service that makes it really easy for millions of AWS customers to securely find, subscribe to, and use third-party data in the cloud. As of today, we also have over 500 product datasets that can be tried for free. All right, so let's actually see a demo here. In this demo, I'm showing how you can get started with prototyping in a local IDE such as PyCharm or Jupyter. And then once you're ready and you want to train at scale, how you can use the same training scripts and go for model training with Amazon SageMaker in the AWS cloud. In order for us to get started here, we need to do a couple of setup steps first. First, make sure you have the AWS CLI installed and configured, so your local environment has access to your AWS account. Also install Anaconda or Miniconda. Once this is done, we can create our Conda environment. In this demo, I'm naming my environment AWS, and I'm setting it to use Python version 3.7. Then we can activate our Conda environment and install any required packages. I'm showing a TensorFlow example, so I'm installing pip, pandas, TensorFlow, and Keras. I'm also pulling in the SageMaker Python SDK with pip install SageMaker. Then I'm installing the Jupyter environment, so I'm doing a conda install, ipykernel, and notebook. And I'm creating a kernel also called AWS, and with that we're almost good to get started here. Just a final note, we're using pre-built SageMaker Docker containers to perform our training locally. So you have to have Docker running in the local environment with Docker Compose or NVIDIA Docker Compose in case you have GPUs available. So I'm switching over to my terminal and we can start the Jupyter environment. So I'm doing an IPython notebook here. And this starts the Jupyter environment on my local machine. As you can see here, I'm on the local host. Let's open a sample notebook. In this notebook, we will perform sentiment analysis with TensorFlow 2. And also note that I'm using the Python AWS kernel I just created. As a quick recap, Amazon SageMaker provides us with a couple of options. We can either use built-in algorithms, or we can train our own custom models together with custom training scripts. And this is the option I'm going to show you here in this notebook. For the sentiment analysis, I'm using the IMDb dataset, which consists of movie reviews labeled as having positive or negative sentiment. And we will train a very simple convolutional neural network to perform the task. We will touch on a couple of Amazon SageMaker functionalities here. One is script mode, which allows us to use pre-built containers to train our custom model with custom training scripts. Then we're using the local mode to perform the training on the local machine. And afterwards, I'm also showing you how you can move to a full-scale training actually in the cloud once you're ready, and leverage multi-GPU instances to speed up the training at scale. And finally, we will also do some predictions to check how our model is performing. So let's get started with preparing the dataset. In the first step, I'm downloading the reviews dataset and padding the reviews so all reviews have the same length. So this is done here. And then next, I'm storing the data in files locally. So I'm creating the data directory and another one for train and for test. I'm also storing some CSV test data to actually do the batch predictions at the very end. After that, we can set up the local mode training. In the first step, you can prepare the local environment with all needed settings for the Docker Compose or NVIDIA Docker Compose easily by using those pre-built scripts which are shared on the GitHub repo pointed out here. Another nice functionality is that you can use a training script which you have in Git. So you don't actually have to pull down your training script to the local environment. You can really just set up a Git configuration here and point it to the script to use. Then in the next step, we need to define the AWS IAM role. So the IAM role, the Identity and Access Management role, which gives us the permission to perform the tasks. In a normal hosted environment, you can do this by simply calling the getExecution role from the SageMaker entity. In this case, because we're training locally on your laptop, you actually have to pull in the full RN of your role. All right, and with that, we can start creating our TensorFlow estimator. So I'm importing the SageMaker Python SDK, and I'm also creating now a TensorFlow estimator object. I'm defining the model directory, and I'm also defining here the training instance type with local. And this setting actually performs the training locally on my machine. Let's set some hyperparameters and let's go easy here on my local laptop. Let's just do one epoch and a batch size of 64 and a learning rate of 0.01. And with that, I can create my local estimator as a TensorFlow object. I'm passing in my git config to find the actual training script. And my training script is here with the entry point called sentiment.py. I'm passing the model directory to use, and I'm passing the instance type, which is set to local. Obviously, I just do a 1 for the instance count here. I'm passing the hyperparameters, I'm passing my role. I'm giving it a job name, and I'm setting the TensorFlow framework version to 2.1, Python version to 3, and I'm enabling the script mode with true. So if we have a quick look at my training script, which I'm pointing out here, I'm opening the sentiment.py. This is just the normal training code you would develop, and we're passing in a couple of hyperparameters through those environment settings here. So make sure you have added those to your training script. And then we're also creating the traditional model training code here. So here you can see how we're building the actual convolutional network. All right, and with that, switching back to my environment here. With that, we are ready to start the training. So for the inputs, I point the model to my local training directory and test data directory. And I'm starting the training by calling fit on the local estimator object we created and passing in those inputs. And this starts the training on my local laptop. Unfortunately, I don't have GPUs installed, so this is going to be a CPU training. And you can see here the outputs. So it's using the training script that we provided and performs the model training locally on my machine. And after a couple of minutes, hopefully you will see the reporting training success. You can, by the way, if I'm switching to my terminal window, check for the Docker containers. So if I do a Docker images, you can see that I have a couple of those TensorFlow container images on my local machine. And the one example we're using here, the TensorFlow 2.1, actually pulled down this image. So make sure you have enough resources. Those images are quite large, 2 GB in size. And this is the reason you need Docker running. We're pulling down the Amazon SageMaker provided TensorFlow training container to perform the training locally. All right, switching back to my notebook here. So we have trained the model locally, and we can prototype and develop the model. And when we're ready to actually train at scale with a larger data set, you might want to consider going and leverage a GPU instance in the cloud. So let's see how we can actually switch from the local mode training to a hosted training on the AWS cloud. In a first step, we need to upload the data to S3. So this is what I'm doing here. And then we can create another estimator object, but in this case, we're setting the training instance to actually use a GPU instance. So here I'm selecting the ML P3 8X large. And if you're unsure which specific characteristics those instances have, you can look it up on the website. And if you're looking here for the P3 instances, you can see that those have the NVIDIA V100 GPUs installed, and the one I'm using here, the P3 8X large, actually consists of 4 times the V100. So a pretty nice instance, and especially suited if we want to train at scale here. So back in my notebook, I'm setting the instance type to this GPU instance. And because we have much more resources now, I'm also increasing our hyperparameters to use 10 epochs and a larger batch size here. And the rest of the configuration is pretty much the same. So the Git configuration to the training script enabled by the script mode true. Source directory, the entry point is my training script pi. And the only change here really that you have to do is change the training instance type to the cloud instance. And doing distributed training, you could increase here the instance count. You can do 1, you can do 5, you can do 10. Whatever you need is suitable for your task at hand. In this case, I'm limiting it to 1 P3 instance to leverage basically the multi-GPUs available within the single instance. So we're setting this up, and here's a little code snippet for you to enable the mirrored strategy to actually utilize all 4 GPUs on the instance. And we're ready to start the training job. So again, I'm calling the estimator fit with my input data. And this now spins up, as you can see, starting the training job, launching requested ML instances. This actually starts the training job now on the AWS cloud. So you can see the logs coming in here and all the training that is being performed. And you can see there's a lot more happening here. And after some time, it finishes and uploading the generated trained model to an S3 location, completed the training job, and you can also see how long the job ran. And if you're switching to your AWS account, to SageMaker and training jobs, you can actually see this training job now being listed in the UI. And if we double check here, we can see our IAM role being used. The training took 188 seconds, and we only got billed for that time. So SageMaker starts the instance, trains your model, and then also spins down the instance again. We've used an ML P3 8X large, 1 instance, and as I said, you can scale this up to as many instances that the job requires. And we can see here input data, where the input data is coming from, for the training, for the test data, and also where we're storing the output model artifacts. Switching back to my notebook. We can then download the model. SageMaker will store the trained model in S3 as mentioned and just shown, but let's actually pull it down here and have a look at the training data. So we can plot the accuracy and the model loss here. So we can see we reached a plateau for the accuracy, so we want to make sure we're not overfitting. And as a final step, let's do some batch predictions, right? We want to test how our model is performing. So again, in SageMaker, you have a couple of options. You can deploy the model on a real-time HTTPS endpoint to do real-time inference, or you can do batch predictions. And batch predictions are really used if you want to have just a batch job predicting on some data. And this is what we're going to do here. I have some sample reviews in a CSV file, and we're using this CSV file here to pass it to the model and collect the predictions. For this, I'm calling an estimator transformer object here. I'm also doing an instance count 1. I'm using, in this case, a C5 CPU-based instance, and I'm passing my text data. So this spins up another cloud instance and performs a batch inference on the CSV data. And once that is done, I can then pull down the data and have a look at it. And actually, let's run some sample queries here. So let's just grab a sample review and see what the predictions are. So in this case, for my data set, I'm pulling a sample and see here the review text. The film was one that I have waited to see for some time, and I was glad to find it. It has been everything anticipated. So I think this is a pretty positive review so far, and we can see by calling the prediction here, by checking the label and the result, that it got labeled for positive and also predicted positive. So this shows how you can set up a local IDE and perform local training. And when you're ready with the prototyping, take the same training script and then perform training at scale in the AWS cloud. So here are a couple of resources for you to get started. First of all, some more sample notebooks on how you can leverage script mode to train your custom models with custom training code. And also a link to the GitHub repo called Data Science on AWS, which I built with a colleague to show you how to perform end-to-end machine learning and data science on AWS, from data ingest, exploration, to model training and deployment at scale. I hope you enjoyed the video and are excited to start building. Thank you very much.